Okay, guys, this warm-up, this is actually an honors level warm-up, so if you're honors, you should be able to handle this, the compound interest formula that you need, which we did go over. If not, then you won't know how to do this question unless you look up that formula. The formula tells you, whoops, I gotta get into pen mode here. Formula tells you that, let's see, A is equal to the principal times 1 plus n, it's not n, it's r divided by n raised to the n times t. The principal is the amount of money you're borrowing or investing, which is $6,000, and then it's 1 plus the rate. Make sure you change that percent to a decimal, so it'd be 0.03. The n is talking about how many times you're going to compound it in a year, and it says it's going to do it annually, so that's out of 1 year, raised to the 1 times t, the number of years, which would be 4. So you've got 6,000 times 0.03 divided by 1 is 0.03, plus 1 would be 1.03 raised to the 4th power. That's going to give me 6,000. If you have a scientific calculator, just take 1.03 and raise it to the 4th power, or multiply it out 4 times. Comes out to an ugly decimal of 1.1255, whoops, going off the board, and it keeps going. And then take that answer and multiply it by 6,000. It comes up to, I'm going to write it over here, $6,753, and rounding it off to 5 cents. So that's how much money you're going to be able to collect back out at the end of 4 years, which means you made, if you think about this, you put in $6,000. So if you subtract that back off, you've made an interest $753.05. All right, 9.2, which is quadratic functions. A quadratic function, which you guys already know, is in the form of y is equal to ax squared plus bx plus c. That's a complete quadratic. If it's missing any one of these 3 terms, then we call it an incomplete quadratic. The axis of symmetry, which is a formula that we've already discussed in the first section, is x is equal to negative b over 2a. If you look on your reference sheet, on the State of Florida reference sheet for Algebra 1 EOC, you will notice that on the quadratic formula equation, the negative b over 2a is hidden within. So it's actually there for you. Make sure you put the equation in standard form first, which means highest exponent first down to lower, before you start pulling out your a, b, and c. Okay, here's our strategy for graphing a quadratic equation, which will be in the form of a parabola. First, find the axis of symmetry. The axis of symmetry is the x equals negative b over 2a. So once you use that formula, that's going to give you your dotted line. And in 9th grade, we're only going to deal with parabolas that open up or open down. We won't deal with the ones that go side to side. So all of our axis of symmetries will be vertical, dotted vertical lines like those. Okay, this will tell you where it is on the graph. The vertex, which is your turning point, is either going to be a minimum, which would be like this, or it's going to be a maximum, which would be like this. It's the turning point. It's where the actual parabola takes a change in direction. That's going to be your negative b over 2a, whatever you came out with from above, comma, your y coordinate. And how do you find this? By substitution. Okay. We also talked about what we have done. We focused in on building a table. If you build a table, don't forget when you do your table, the easiest thing to do is to put your vertex in the middle and then build 2 above, 2 below. You also could do a x and y intercepts if you decide to do the x and y intercepts, which is an alternative method. To find the x-intercept, you substitute 0 and 4y, and plot that point. To find the y-intercept, you do the opposite. You substitute 0 and 4x and find that point and plot it. Don't forget to put arrows on it because we know it goes on to infinity, and don't forget to label it with the original equation. Okay, we're going to go ahead and do one together right now. All right, I'm going to rewrite this equation. Oh, I don't think I need to. This is a complete quadratic. It's got all three terms, the ax squared plus bx plus c. The a is actually equal to the 1, so I'm going to jot this down. A is equal to 1, b is equal to -6, and c is equal to 4. Make sure you organize your work and show every step clearly. First thing I'm going to find is my axis of symmetry. Guys, also make sure you have graph paper. The axis of symmetry is the formula negative b over 2a. Be careful, the formula has a negative in it, so just bring that over. And then when you put the b in, which is a -6, that's obviously going to make that positive, divided by 2 times a. So you end up with 6 divided by 2, which is at 3. Grab a straight edge. We're going to draw our dotted line at x equals 3. So that's going to be right here. That's my axis of symmetry. I'm going to label it x equals 3. Step number 2. Make sure you guys put me on pause if I'm going too fast. Don't forget I'm running against the clock here. The vertex is the point. In this case, because a is positive, we know the parabola is going to open up, which means your vertex is going to be a minimum. Okay, that is going to be at 3, comma, my y-coordinate. I find the y-coordinate by substituting 3 back into the original equation. So I get 3 squared minus 6 times 3 plus 4. 3 squared is 9 minus 18 plus 4. 9 minus 18 is -9, and -9 plus 4 is 5. -5, excuse me. So that means 3 comma -5 is my minimum point, which is the vertex. So I go to 3 comma -5. It should land right on my it should land right on my axis of symmetry. 1, 2, 3, 4, 5. So make that nice and big point so we can see it. Step 3. Step 3, I'm going to build my table. Now remember, when you build your table, the easiest way to do it is to put your vertex in the middle. That's my 3, -5. Now I'm going to do 2 numbers smaller and 2 numbers bigger. So when we substitute these in, I'm going to get 1 squared minus 6 times 1 plus 4. That's 1 minus 6 is -5, and -5 plus 4 is -1. Putting in my 2, I get 2 squared minus 6 times 2 plus 4. That's 4 minus 12 is -8. -8 plus 4 is -4. Put in my 4. That would be 4 squared minus 6 times 4 plus 4. I've got 16 minus 24 is -8. -8 plus 4 is -4. Notice how these guys are coming out the same. They should, because they're symmetric or symmetrical. So we get 5 squared minus 6 times 5 plus 4. That's 25 minus 30 is -5 plus 1, or -5 plus 4 is -1. And these guys are symmetrical as well. So let's go ahead and plot these points. We get 1, -1, 2, -4, 4, -4, and 5, -1. When you sketch it, just try to be careful. Make sure when you come down here, don't make it a V. It's actually a U. You don't want it to look like absolute value when it's not. Y is equal to x squared minus 6x plus 4. And there it is. The domain is equal to everything on the x-axis will touch, so it's all the real numbers. However, the range, the smallest point on the range, the y, which is right down here, which is at -5, so the range is all the numbers that are greater than or equal to -5. So that would be the domain and the range. Okay, this problem is tricky. Let's be careful. They're not using x and y, they're using h for height and t for time. Go ahead and write the equation down and get your graph paper ready. Let's read this. It says, during halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with initial upper velocity of 72 feet per second, and the t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is the maximum height, and what is the range of the function that models the height of the t-shirt over time? Notice how the t-shirt's starting 5 feet above ground. That's where this is coming from. Okay, so I'm going to go ahead and rewrite this on my graph. So it's negative 16t squared plus 72t plus 5. All right, so let's look at what I have set up here. Here's my equation. First thing I'm going to do is I'm going to figure out what my axis of symmetry is. That's the A is equal to negative 16, B is equal to 72. We're going to need our calculator for this. And C is equal to 5. So x equals negative B divided by 2 times A. So that's negative 72 divided by 32, negative, it's going to come out to a positive 2.25. Whoops. So that's the time. Okay, so I'm going to draw my line at 2.25. That would be 1, 2, right about here. So let me go ahead and draw my line at right around 2.25, roughly speaking. And then we're going to find the vertex, which is going to be 2.25 comma something. Whoops, it's not y, it's h. So we're going to get negative 16 times 2.25 squared plus 72 times 2.25. Plugging this all into a calculator, we're going to get, let's see, 2.25 times 2.25, then multiply that by negative 16. We get negative 81 plus 72 times 2.25 comes out to 162 plus 5. So I'm going to take my 81, subtract that, plus 5. So that comes out to, simplifying it down to 86. That's my height. So at 2.25 seconds, it reaches 86 feet in the air. So let's see, 5, 10, let's see, if I go by 5s, will I make it? 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85 would be right here. So just above that would be my maximum point, my vertex. At 2.25 seconds, it hits 86 feet. So we now know it takes 2.25 seconds to reach max of 86 feet in the air. Okay? We also know that it started at 5 feet above the ground. So we actually know that I'm not going to be able to do this on the inner right, but it's going to go up, it's going to hit there, and it's going to come back down, and it's going to hit the ground somewhere. Okay, and I am going to run out of time. So what you guys will have to do to figure out where it hits is you'd have to figure out what the x-intercept is, which means put 0 in for my y, which really means you actually have to factor this. Okay, and that's actually quite tricky, but you would have to, there's no GCF, you'd have to factor that and